Download this code from codegive.com, link in the description below. OK, let's dive deep into the fascinating world of best approximation and least squares in linear algebra. This is a fundamental topic with wide applications in data fitting, machine learning, signal processing, and much more. We'll cover the theory, the mechanics, and practical code examples using Python and NumPy. 1. Problem setup, the overdetermined system. The core idea behind best approximation and least squares arises when we have a system of linear equations that is overdetermined. What does that mean? Consistent system. A system of equations is consistent if it has at least one solution. If x equals b is consistent, there's a vector x that satisfies the equation perfectly. Overdetermined system. A system x equals b is overdetermined if it has more equations than unknowns, more rows than columns in the matrix A. Think of trying to fit a line to many data points. There might not be a perfect line that goes through every point. In other words, b might not be in the column space of A. The challenge if an overdetermined system x equals b is inconsistent, no exact solution exists, we want to find the best approximate solution. Best is usually defined in the sense of minimizing the error, or the difference between x and b. 2. The least squares solution, minimizing the error. The most common way to quantify the best approximation is using the Euclidean norm, or the 2 norm, of the error vector. Error vector E equals x, b. Error magnitude, 2 norm E equals x, b equals sqrt, x, b, sub t slash sub, x, b. The least squares solution x underscore hat is the vector x that minimizes x, b. In other words, we want to find x underscore hat such that x underscore hat, b equals x, b for all possible vectors x. 3. The normal equations, finding the optimal solution. Calculus is used to find the minimum. The key is that at the minimum of x, b sub 2 slash sub, the gradient with respect to x must be 0. This leads to the normal equations. A sub t slash sub x underscore hat equals a sub t slash sub b. Where a sub t slash sub is the transpose of the matrix A. Solving for the least squares solution if the matrix A sub t slash sub A is invertible, which is guaranteed if the columns of A are linearly independent, then the least squares solution is x underscore hat equals a sub t slash sub A, sub dash 1 slash sub A sub t slash sub B. Important this is a crucial formula. It provides a way to calculate the best approximate solution to an overdetermined system in the least squares sense. 4. The projection interpretation, geometrically understanding the solution. There's a beautiful geometric interpretation of the least squares solution. The vector x underscore hat is the orthogonal projection of the vector b onto the column space of the matrix A. Column space of A, col, A, the set of all possible linear combinations of the columns of A. It's a subspace of R sub m slash sub, where A is an Mxn matrix. Orthogonal projection, proj sub col, A, slash sub, B, the vector in col, A, that is closest to B. The vector B, proj sub col, A, slash sub, B, is orthogonal, perpendicular, to every vector in col, A. The least squares solution x underscore hat is the vector that, when multiplied by A, gives you the projection of B onto col, A. X underscore hat equals proj sub col, A, slash sub, B. Why does this minimize the error? because the distance between B and its projection onto COL, A, is the shortest distance between B and any vector in COL, A. 5. Least squares problems and linear models. A very common use case for least squares is in fitting linear models to data. Suppose you have a set of data points, x sub 1 slash sub, y sub 1 slash sub, x sub 2 slash sub, y sub 2 slash sub, x sub n slash sub, y sub n slash sub. You want to find a line, or a more complex linear function, that best fits these points. Asterisk linear model asterisk y equals mx plus c, where m is the slope and c is the y-intercept. You can set up an overdetermined system of equations in matrix form, where now, you can use the least squares solution to find the best values for m and c that minimize the difference between the predicted y values and the actual y values. 6. Algorithm and code example, Python with numpy. Here's a Python code example demonstrating how to find the least squares solution using numpy. Explanation of the code asterisk. 1. Import libraries asterisk numpy for numerical computations, matplotlib.pyplot for plotting. 2. Create data asterisk x and y arrays represent the data points. 3. Construct matrix A asterisk. Asterisk np.column underscore stack, combines the X array and a column of ones to create the A matrix. Asterisk the column of ones is essential for including the intercept, C, in the linear model. 4. Construct vector B asterisk the Y array becomes the B vector. 5. Calculate least squares solution asterisk. Asterisk method 1. Normal equations. This method calculates a sub t slash sub a sub t slash sub b, and then solves, a sub t slash sub a, x underscore hat equals a sub t slash sub b using np.linalg.solve. Asterisk important check asterisk before inverting a sub t slash sub a, it's crucial to check if it's invertible. You can do this by calculating its determinant, np.linalg.det. If the determinant is close to 0, the matrix is nearly singular, ill-conditioned, and inverting it directly can lead to numerical instability. In such cases, consider adding a regularization term. Asterisk method 2, numpy's lstsq np.linalg.lstsq, is a more robust and recommended way to find the least squares solution. It uses more advanced numerical algorithms that are less sensitive to ill-conditioned matrices. It returns the solution, residuals, rank, and singular values. The recond equals none argument tells lstsq to use the rank of the matrix to determine which singular values to consider significant. 6. Extract results asterisk the solution x underscore hat contains the slope, m, and intercept, c. 7. Create best fit line asterisk the code calculates the predicted y values based on the linear model and the found slope and intercept. 8. Plotting asterisk the code uses matplotlib to visualize the data points and the best fit line. Key points and considerations asterisk. Asterisk full rank asterisk the matrix A should have full column rank for the least squares solution to be unique. If A does not have full column rank, the null space of A will have a non-zero vector, so there will be more than one vector x such that x is the orthogonal projection of B onto COL, A. Asterisk numerical stability asterisk for very large matrices or matrices that are close to singular, use numpy's lstsq function. It's generally more reliable than directly inverting A sub t slash sub A. Asterisk residuals asterisk the residuals represent the sum of squared errors. They provide a measure of how well the model fits the data. Smaller residuals indicate a better fit. Asterisk regularization asterisk if A sub t slash sub A is nearly singular, regularization techniques, like ridge regression or Tikhonov's regularization, can be used to improve the stability of the solution. Regularization adds a term to the normal equations, a sub t slash sub a plus lambda I, x underscore hat equals a sub t slash sub b, where lambda is a regularization parameter and I is the identity matrix. Asterisk different error metrics asterisk while the least squares solution minimizes the 2 norm of the error, other error metrics can be used, example minimizing the 1 norm or infinity norm. These lead to different optimization problems. Asterisk generalized least squares asterisk if the errors have different variances, you can use weighted least squares to account for the different levels of uncertainty. Beyond the basics, applications and extensions. Asterisk polynomial regression asterisk you can fit higher order polynomials to data using the same least squares framework. Instead of y equals mx plus c, you might have y equals ax sub 2 slash sub plus bx plus c. You just need to modify the A matrix accordingly. Asterisk multiple linear regression asterisk this extends the concept to multiple predictor variables. For example, y equals b sub 1 slash sub x sub 1 slash sub plus b sub 2 slash sub x sub 2 slash sub plus b sub k slash sub x sub k slash sub plus c. Asterisk machine learning asterisk least squares is the foundation of many machine learning algorithms, including linear regression, logistic regression, with a transformation, and support vector machines, SVMs. Asterisk image processing asterisk least squares can be used for image restoration, denoising, and other image processing tasks. Asterisk signal processing asterisk used in filter design, signal reconstruction, and spectral analysis. In summary asterisk the least squares solution is a powerful tool for finding the best approximate solution to overdetermined systems. Understanding the theory and having the ability to implement it in code is essential for various applications across science, engineering, and data analysis. Practice with different datasets and explore variations like regularized least squares to deepen your understanding.